next paper, is entitled Line Balancing in Assembly Line Automotive Carrossery, Body of a Car Production Process at PT XYZ. And this paper is written by Mbak Melinia Novita Pratama and Ibu Lina Gozali from the Department of Industrial Engineering, Faculty of Engineering, Universitas Tarumanagara, Jakarta, Indonesia. Mbak Melina Novita Pratama, are you here already?
Yes, I'm here already.
Okay, time is yours, and you have around 10 minutes to present your ideas as written in the paper, please.
Okay. So I've done my share screen. Can you see my slide?
Yes, please present. Yep.
Okay. I will start my presentation. Good afternoon to all professor, judges, ladies and gentlemen. Thank you for the opportunity. It's great to see you all. Let me introduce myself. My name is Melinia. I'm a 7th semester student of the Industrial Engineering from Universitas Tarumanagara. In this opportunity, I would like to present about line balancing in assembly line automotive carrossery or body of a car production process at PT XYZ. This is the outline for today. There are introduction, literature review, research methodology, data collection, results and discussion, conclusion, and references. So PT XYZ is a company engaged in manufacturing and producing cargo box, flatbeds, and types of transportation according to the needs and desire of consumers. PT XYZ also offer for maintenance and repair. PT XYZ want to increase the production efficiency, achieve optimal production capacity, and calculate the right amount of operator at the workstations. So the line balancing method can analyze the problem. This method is expected to provide a solution as an alternative to improve the balance performance of the production line by minimizing the balance delay and smoothness index, optimizing the balance efficiency, and decrease the number of workstations. Production PT XYZ in the last year was 862 units, but due to the pandemic, PT XYZ used only production lines. For the literature review, there are a cycle time measurement using a stopwatch to calculate the time of its movement that occurs. And then there are adjustment factor, the adjustment factor using the Westinghouse method, which is determination of the rating on skills, effort, working condition, and consistency. Each factor is then subdivided into super skill, excellent, good, average, fair, and poor. And then there's normal time. The normal time is the time used by a worker to work fairly without excessive and the working day. And then there's allowance. Allowance consists first of allowance for personal needs, including such as drinking, going to the toilet, eating, working, etc. And the second allowance is allowance looseness to relieve fatigue. And the third allowance is allowance for obstacle is inevitable. And then there is standard time. Standard time is when a normal worker takes to complete a job carried out in the best work system. And then there are line balancing. Line balancing is a balancing method for assigning test element from an assembly line from an assembly line to a workstation to minimize the number of workstations and minimize the total idle time at all stations. There are procedures to apply the line balancing method. The procedure should be performed include the first step is make the precedence diagram. Precedence diagram is made with circle symbol or not, arrow, and standard time. And then we calculate the cycle time. Cycle time in here is different with the cycle time previously because the cycle time is here because the cycle time here is only to count the number of workstation, and then we calculate the theoretical minimum number of workstation, This calculation shows theoretically the minimum number of workstations needed on a production line. And then step 4 is we calculate the balance efficiency. The calculation of balancing efficiency is intended as a parameter of the success of the line balancing. And then we calculate the balance delay. Balance delay is the percentage of idle time in a production line because the distribution of operation between stations is uneven. And we calculate the smoothness index. Smoothness index is a way to measure the relative idle time of a production line. The minimum value of the smoothness index is 0 or perfect balance. If the smoothness index value is getting closer to 0, then the production line is getting more balanced. For the heuristic method, I use 4 methods. There are rank positional weight. Rank positional weight method is a weight value is a calculation between the work element and the position of each work element in the precedence diagram. And I use largest candidate rules. Largest candidate rules is the basic principle of the largest candidate rules method is the combined processes based on the sequencing, the largest operation processing time to the shortest operation time. And then I use Kilbride-Western method. The Kilbride-Western method is a heuristic procedure that selects work element for assignment to a workstation according to their position in the preferred precedence diagram. And the last method, I use Moody-Young. Moody-Young method is a line balancing method that has two phases or steps of analysis. Phase 1 is to group workstation based on a matrix of relationship between elements. After that, we can calculate the goal value. And if there is time that is smaller than the goal, then the work element can be moved to the minimum workstation, and the next step is doing the phase 2. Phase 2 is carried out to distribute idle time evenly for each station resulting from phase 1. And then I use ProModel to validate the result. ProModel is an application program that is used to simulate a system and analyze the production system. For the research methodology, first steps is I observe in the field and then do a literature study. Then collecting data using stopwatch on the assembly line at PTXZ. And then I calculate the standard time with adjustment and allowance factor. Then process using heuristic method include rank positional weight, largest candidate rules, Kilbride-Western, and Moody-Young. And then I validate the result using ProModel. And then analyzing the result, and we got conclusion, and then finish.
2 minutes remaining.
Here are some data of cycle time of each task element in the assembly line at PTXZ. I collect 40 data for each task element, so the total time for the cycle time is 130.66 minutes. And after that, I write the adjustment factor of each task element. Here are the adjustment factor. From the adjustment factor, we can obtain the normal time. And then and then I collect the allowance. From the allowance, we get the standard time. Here are the precedence diagram before line balancing. And then from the precedence diagram, we can get the balance efficiency, smoothness index, cycle time, and theoretical minimum of workstation. After that, I process using heuristic method, and there are precedence diagram after line balancing. There are minimized workstation from 6 to 3 workstation. And then there is a result using 4 methods, and the result using 4 methods are the same. I prepared the video of simulation using ProModel, so let's see the video. Good morning, everyone. I will show you the simulation before line balancing. Before line balancing, there was 6 workstation, and in this application, we can set runtime according to our wishes in the option. And for the simulation, we just click simulation and click run. Maybe it cannot be visible if I click the run. Okay, so we wait a moment until the simulation is complete. And then we can just click yes if we want to see the results. It may be not be visible too. Now the output viewer will appear and we can see the schedule time in location. The schedule time is 8 hours and we can say the total entries in the system is 3 units and we can see the total exits in system is 3 units. The results of the pro-model simulation before line balancing is a product output of 3 units, which shows that the simulation on the line is in accordance with the theoretical calculations. Next is a simulation after line balancing. This is the layout after line balancing. As you can see, there are a reduction from 6 workstation to 3 workstation. The steps are the same as in the previous video, so I will
Excuse
just
me, the time is up.
So, yeah, could you please speed up your presentation, please?
Okay, so this is for the conclusion. There is a chance in the number of workstation from 6 workstation to 3 workstation. The balance efficiency increased from 42.79% to 82.98%. The balance delay decreased from 57.21% to 17.02%. The smoothness index in the 4 metals are had the same value. It's 77.02 minutes. The production capacity increased from 6 unit to 7 unit. So the company can exceed the target they set. And there was a reduction of operators from 4 to 3 people. Here are the references that I used in writing this research. And that is all from me. Thank you for your attention. Have a nice day.
You too. Thank you, Melinia. Sorry. Thank you very much for the presentation.